Hello everybody. Today we're going to be working with our sum and difference formulas. The 6 formulas are here. There's one where we're adding alpha and beta, that would be 2 separate angles, and the other where we are subtracting. We use these formulas to find exact values for trig functions that are not on our unit circle. The important part here is that we are looking for exact values, so we're going to be getting some crazy looking radicals as we go through these. Good news is though, guys, we will be getting a formula sheet with us during the assessment for the sum and difference and the rest of the formulas in the next unit as well. So let's get started. We want to find the sine of 75 degrees, and what you want to do is think of 2 angles on our unit circle that would either sum or subtract to be 75. So all of us may be coming up with different answers. The simplest one I saw was the sine of 30 plus the sine of 45. Now looking at our first formula on the left-hand column here, alpha is going to be 30, beta is going to be 45. Plugging everything in, the sine of 30 times the cosine of 45 plus the cosine of 30 times the sine of 45. We know the values for all of these, so the sine of 30 degrees would be 1/2. The cosine for 45 would be square root of 2 over 2. Cosine of 30, square root of 3 over 2. And sine is square root of 2 over 2. At this point, we're kind of done with the trigonometry side. The rest is going to be combining up like terms and rationalizing any denominators if we get there. The first term here is going to be square root of 2 over 4 plus square root of 6 over 4. Since they have common denominators, they can be written as one fraction. Square root of 2 plus the square root of 6 over 4 is our final answer. Okay, moving on to cosine of negative 5 pi over 12. Remember, for cosine, the negative will be absorbed. So we also could be looking for the cosine of positive 5 pi over 12. For me, it's easier if I make a little list to the side to get all my common angles in terms of 12ths. So for example, pi over 6 is the same thing as 2 pi over 12. Pi over 4 is equal to 3 pi over 12. Pi over 3 would be the same thing as 4 pi over 12. And pi over 2 is the same as 6 pi over 12. So I'm looking to find some here that will get me 5 pi over 12. So if I add these two guys together, we get 5 pi over 12. So what I'm going to be working with is the cosine. I'm going to rewrite this as pi over 6 plus pi over 4. So we're going to be using our second formula down on the left. Alpha is going to be pi over 6. Beta is going to be pi over 4. So filling everything in, I'm looking at the cosine of pi over 6. Cosine pi over 4 minus sine of pi over 6, sine of pi over 4. I'm going to evaluate each of these angles. So the cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. Sine of pi over 6 is 1/2. Sine of pi over 4, square root of 2 over 2. Following PEMDAS multiplying first, we get square root of 6 over 4, square root of 2 over 4. And again, since they have the same common denominator, we're going to rewrite as a single fraction. Okay, while I still have this chart up here, we're going to figure out tangent of 25 pi over 12. Then I'm going to scoot the screen down a little bit. First, I'm going to take a coterminal angle with this. I'm really going to look to find the tangent of pi over 12. Because remember, we split each semicircle into 12 equal parts. If I subtract 24 pi out of here, I wind up with a coterminal angle. So I want to look here to see which two values would get me pi over 12. And the same two that are circled, if I subtract these two, will get me just a single pi over 12. So we're going to turn this into the tangent of, let's see, pi over 4 minus pi over 6. All right, I'm going to just scoot the screen down, and we'll continue. So we had decided that we're going to find the tangent of pi over 4 minus pi over 6. So we are looking at the last formula over on the right side here, tangent of alpha minus beta. Pi over 4 is alpha, pi over 6 is beta. Filling everything in, we get the tangent of pi over 4 minus the tangent pi over 6 all over 1 minus the tangent of pi over 4 times the tangent of pi over 6. All right, so the tangent of pi over 4 is 1. The tangent of pi over 6 is square root of 3 over 3. This one here is in the formula. Guess this tangent's 1 is going to be multiplied to this piece here, and we already decided that the tangent of pi over 6 is square root of 3 over 3. We want to get rid of these denominators here, so I'm going to multiply all 4 terms through by 3. Distributing through, 3 times 1 will get me 3. This 3 and this 3 here will cancel, leaving us with minus square roots of 3. 3 times 1 is 3, and again, the square root of 3's will cancel here and here, leaving us with plus square root of 3. We do need to rationalize this denominator, so I'm going to multiply through by the conjugate. So in the numerator, 3 times 3 will get us 9, minus 3 square roots of 3, minus another 3 square roots of 3 would be minus 6 square roots of 3, plus 3 on the end there. Since they're conjugates, we do not need to look at the O and the I of the FOIL, so 3 times 3 is 9, and that's going to get us minus 3. Let's just combine up some terms here. 9 plus 3 will get us 12 minus 6 square roots of 3 all over 6, which will eventually simplify down to 2 minus the square root of 3. Okay, so that was the tangent problem. Let's move on to number 4. We're looking to find the exact value of this right here. And what I'm noticing is that is the sine of alpha minus beta formula, where the alpha is equal to 20 and the beta is equal to 80. Okay. So this is really the sine of 20 minus 80, which is the sine of negative 60 degrees, which would put us down here in quadrant 4 at negative 60, and the sine value for that is negative square root of 3 over 2. All right, let's take a look at problem number 5. Looks a little bit more complicated than it actually is. It tells us that the cosine of alpha is square root of 5 over 5, and it's located in quadrant number 1. So there's quadrant number 1. This is angle alpha. I do know that cosine is the adjacent over the hypotenuse. And using Pythagorean's theorem to get the third side, we'd wind up with 2 square roots of 5. Then it tells us that sine beta is negative 4 over 5, and beta is between negative pi over 2 and 0, which puts beta in quadrant number 4. So I'm listing that as angle beta. I do know that sine is y over the hypotenuse. So here's your minus 4. Here's 5. This is one of the Pythagorean triples. Now it's asking me to find the exact value of cosine of alpha minus beta. Alright, so I'm looking for the cosine of alpha, I'm putting into the formula, times the cosine of beta, plus the sine of alpha, times the sine of beta. Alright, so if I'm looking for the cosine alpha, we were told that, that's the square root of 5 over 5. The cosine of beta would be 3 over 5 coming from our second triangle there. The sine of alpha is going to be 2 square roots of 5 over 5. And the sine of beta, we were given that one also, that was negative 4 over 5. Combining up both these terms, we got 3 square roots of 5 over 25 minus 8 square roots of 5 over 25, which becomes minus 5 square roots of 5 over 25. The outside parts simplify, leaving us with a final answer of negative square root of 5 over 5. So again, notice we have no decimals here. We're always looking for these exact values. Okay, scoot your paper over. Let's look at number 6. We're looking to find the exact value of these guys. So I'm going to let this become, alpha become the inverse sine of 4 over 5. Since it's positive, it would have to be in quadrant 1. There's my angle alpha. If it's sine, this is 4, this is 5. A Pythagorean triple or Pythagorean theorem will get you through there. I'm going to let beta equal the inverse tangent of 3 over 4. Since it's positive, it would have to come from quadrant number 1 as well. So there's our beta. Tangent is the opposite over the adjacent. Again, another Pythagorean triple here. So I'm really looking to find the sine of alpha minus beta. That's going to be our first formula in the right-hand column here. So it's going to be the sine of alpha, cosine of beta, minus cosine of alpha, sine of beta. And we're going to use our triangles to get our values. The sine of alpha would be 4 over 5, opposite over hypotenuse, or y over r. Cosine would be 3 over 5. Cosine of alpha is 3 over 5. And the sine of beta, let's see, the sine of beta is 3 over 5. That is going, this was a 4, guys, I'm sorry. Let me just double check this for 1 second. The sine of alpha is 4 over 5. Cosine of beta was also 4 over 5. Yep. So that is 16 over 25 minus 9 over 25, which got us a total of 7 over 25. And that cannot be simplified any further. All right, number 7 is an identity using these formulas. Again, if we do pull identities out, you will have that formula sheet in front of you. Do not need to memorize these. So the cosine of alpha plus beta would be cosine alpha, cosine beta, minus sine alpha, sine beta. The cosine of A minus B would be cosine alpha, cosine beta, plus sine alpha, sine beta. I do notice that the sine terms will cancel, and these guys are exactly the same. So if I have 2 of the same thing, now I have 2 cosine alpha, cosine beta. So that one actually turned out to pretty simple. Looking at number 8, This is again already in the formula, so you want to recognize which formula that we have. This is the tangent sum formula is what we're looking at here. So alpha here is going to be 20, beta is 25. So this is really the tangent of 20 plus 25, which is the tangent at 45 degrees, which would get us 1 when we go to y over x and the coordinate square root of 2 over 2 for a 45-degree angle. Looking at part B here, I look at this and I notice this to be the cosine difference formula. So the alpha here is pi over 12, the beta is 5 pi over 12. So what we're really looking at is the cosine pi over 12 minus 5 pi over 12, which gets you the cosine of minus 4 pi over 12, which reduces to the cosine of negative pi over 3. When I'm at negative pi over 3, the coordinates are 1/2, negative square root of 3 over 2. We're looking for the cosine of that, so we will get 1/2. Okay, we just have one more with 2 little examples to do, and we'll be done with this lesson. We're just looking to simplify the expression. This is a sum formula for sine. So it's going to be the sine of x times the sine of 2 pi. No, it's not. I lied. Times the cosine. Sorry, folks. Times the cosine of 2 pi plus the cosine of x times the sine of 2 pi. So at 2 pi, we're sitting right here. The cosine is, when we're at 2 pi, the cosine is 1. And then we are looking here, the sine at 2 pi is 0. So this whole term will drop, and what we are left with is sine x. All right, and let's just try this last one with the tangent. It is a tangent sum formula. So the tangent of x plus the tangent of pi all over 1 minus tan x times the tangent of pi. At pi, we are here at the point negative 1, 0. And again, tangent's y over x, so it's going to be just 0 here. So it's going to get you tan x plus 0 over 1 minus tan x times 0. So that will go away as this, and we simplify to tan x. That ends today's lesson. Good luck with the practice, everyone.